Welcome to Math with Mr. J. In this video, I'm going to cover how to write numbers in scientific notation. We will start with large numbers, move to small numbers, and then end with some practice problems that you can try on your own. Now remember, scientific notation is a way for us to write really large numbers or really small numbers in a shorter, more condensed way. This helps make really large and really small numbers more manageable and easier to work with. For example, we have this really large number right here. This number goes to the trillions, and this is actually the number of miles light travels in 1 year. This is what we call a light year, which a light year is, again, the distance light travels in 1 year. Light years are used to measure very far distances in space. Now, working with numbers like this and writing numbers like this can be difficult, tedious, and take up a lot of space with all of those digits, all of those zeros. So we use scientific notation to condense them, to write them in a simpler form. Here's that number in scientific notation. So we can see how that number was condensed. It was shortened, but it's still equal to the number above. Now, when it comes to scientific notation, we're going to have a number that is greater than or equal to 1, but less than 10. And we're going to multiply that by a power of 10. Now, keep in mind, these are equal. 5.88 times 10 to the power of 12. So the scientific notation is equal to this number. So how do we go from this to this? Well, let's jump into our examples, starting with number 1, where we have 6,500. We're going to start smaller than the example above and work our way up. Now, basically, all we need to do here is move the decimal to the right of the first non-zero digit. So anything 1 through 9. And we count how many places the decimal moved. That will give us everything we need to write the number in scientific notation. So looking at this number and reading it from left to right, what's the first non-zero digit that we come across? Well, this 6 right here. So we need the decimal to the right of that. So right here in between the 6 and the 5. So let's move the decimal there. And the decimal comes after the ones place, to the right of the ones place. Basically, just put it after a whole number. So right here. And we need to move it once, twice, 3 times. So the decimal is going to go right here. So what we do, we write 6.5. Now we need to leave any zeros to the right off. We don't need those. We are condensing this number. And then we need to multiply this by a power of 10. Now we need an exponent. And our exponent is going to be how many places the decimal moved. And that was 3. So we need an exponent of 3 here. And this is our scientific notation. 6.5 times 10 to the power of 3. This is equal to 6,500. We have a number greater than or equal to 1, but less than 10, times a power of 10. Now, I do want to mention before moving on to number 2 that when we have scientific notation with a positive exponent, we are working with large numbers. When we have a negative exponent, we are working with really small numbers, and we will get to those next. Let's move on to number 2, where we have 19 million. So we need to start by moving the decimal to the right of the first non-zero digit. So looking from left to right here, our first non-zero digit is this 1. So we need to move the decimal right here in between the 1 and the 9. The decimal goes right here, and we need to move it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. Now we can write this in scientific notation. So we write 1.9 and we leave all of the zeros to the right off times, and now we need our power of 10. So how many places did the decimal move? Well, 7. So that is our exponent. And this is our scientific notation for number 2. 1.9 times 10 to the power of 7. Moving on to number 3, let's write this number in scientific notation. So we need to find that first non-zero digit, which that's going to be this 7 right here. And we need the decimal to the right of that. So in between the 7 and the 0. The decimal goes right here. And now let's move it. So we have once, twice, 3 times, 4, 5, 6, 7, 8, 9, and 10. So we need to write this as 7.082, and then we can leave all of those zeros to the right off, times our power of 10, which is going to be 10 to the power of 10 since we moved that decimal 10 times. And this is our scientific notation. 7.082 times 10 to the power of 10. Lastly, let's move on to number 4. So let's find that first non-zero digit, which is going to be this 4 right here, and we need to move the decimal to the right of that. The decimal goes right here after the ones place, after the whole number, and now let's move it. And since we have a lot of zeros here, one thing we can do is move the decimal in groups of 3. We don't have to do it this way, but I at least wanted to show this. It can be helpful and quicker when working with numbers with a lot of zeros. For example, 3, 6, 9, 12, 13, and 14. So we can write this as 4, and then we leave all of those zeros to the right off, and we just have a 4 here, a whole number. We don't have any decimal digits to include. We just have zeros to the right, so this is fine. Times 10 to the power of 14. And this is our scientific notation. So there you have it. There's how to write large numbers in scientific notation. Let's move on to writing small numbers in scientific notation. Now let's take a look at writing small numbers in scientific notation. For example, we have this number right here. Let's say that this is the diameter of a cell, so 0.000072 meters. So we have a measurement of something that is very small here. So here is that number written in scientific notation. We have a number to start with right here, 7.2, that is greater than or equal to 1, but less than 10 times a power of 10. And this is equal to the number above. So how do we go from this to this? Well, let's jump into our examples, starting with number 1. Now this is going to be very similar to when we write large numbers in scientific notation. We move the decimal to the right of the first non-zero digit, so anything 1 through 9, and we count how many places the decimal moved. That will give us what we need to write something in scientific notation. With small numbers, though, we will move the decimal to the right and use negative exponents, which we will talk about here shortly. So those two things do differ from when we have large numbers. So looking at our number here, we are reading it from left to right. What's the first non-zero digit that we come across? Well, it's going to be this 1 right here. So we need to move the decimal to the right of that 1. So we need to move the decimal once, twice, 3 times, 4 times, 5 times, and 6 times. So we moved the decimal 6 places to the right. So what we do now, we write 1, and we just have a whole number here. We don't have any decimal digits for this one, so we just have 1. And all of those zeros to the left of 1, we leave off. We don't need those. And then we multiply that by a power of 10. So 1 times 10, and now we need an exponent. So what power of 10 here? Our exponent is going to be how many places we moved the decimal. And since we are working with a small number here, this is going to be a negative exponent. Well, we moved the decimal 6 places, so our exponent here is going to be negative 6. So we have 1 times 10 to the power of negative 6. And that's our scientific notation. Now we're using a negative exponent here. We want to multiply by that negative exponent because this is a way to represent division or taking a fraction of something, which gives us that smaller number. Remember, a negative exponent just means we can turn it into a fraction with a numerator of 1 with a positive exponent in the denominator. So 10 to the power of negative 6, let me write this up here. So 10 to the power of negative 6 equals 1 over 10 to the power of positive 6. And 10 to the power of 6 equals 1 million. So this is actually 1 over 1 million, 1 millionth. So looking at our scientific notation, we have 1 times 10 to the power of negative 6, which this just means 1 times 1 over 10 to the power of 6, or 1 times 1 over 1 million, which all of this is the same as dividing by 1 million. Multiplying by 1 over 1 million is the same as dividing by 1 million. And that gives us our original decimal. So with small numbers, we use a negative exponent because that's going to give us those small numbers. Keep in mind, this is equal to this. Let's move on to number 2, and we need to start by finding the first non-zero digit. So looking from left to right, this 3 is the first non-zero digit. So we need to move the decimal to the right of that. So we need to move it once, twice, 3 times, 4 times, 5 times. So the decimal goes right here. So all we need to do now is write 3.8 times, and now we need our power of 10. So our exponent is going to be how many places we moved the decimal. That was 5. And we're working with a small number here, so we need a negative. So this is 10 to the power of negative 5. So for our scientific notation, we have 3.8 times 10 to the power of negative 5. Let's move on to number 3, and we can start by looking at this number from left to right and finding that first non-zero digit. So what's the first non-zero digit that we come across? Well, this 4 right here. So we need to put the decimal to the right of that. Let's move the decimal. So once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times. So the decimal is to the right of that first non-zero digit now. So we write out 4.025. And now we need to multiply that by a power of 10. So times 10 to the power of, well, how many places did we move the decimal? 9. So we need a negative 9 here for our exponent. So 4.025 times 10 to the power of negative 9, and that's our scientific notation. Lastly, moving on to number 4, we need to start by finding that first non-zero digit. So looking from left to right, that's going to be this 9 right here. So let's move the decimal to the right of that. We need to move the decimal once, twice, 3 times, 4 times, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 9.7 times 10 to the power of negative 13. And that's our scientific notation. So there's how to write small numbers in scientific notation. And now that we've covered large and small numbers, let's try some practice problems. So here are our practice problems. Have a piece of paper and pencil ready, and you can try these on your own. Feel free to pause the video and give these a try, or let the video play and I'll give you 3 minutes. Whenever you're ready, click ahead to the answers and see how you did. So write each of these in scientific notation. Go ahead and start. Okay, so let's take a look at the answers here and see how you did. So here are our answers. For number 1, we have 1 times 10 to the power of 7. For number 2, we have 8.2 times 10 to the power of negative 5. For number 3, 2.095 times 10 to the power of 11. For number 4, 5 times 10 to the power of negative 8. For number 5, 9.94 times 10 to the power of negative 9. And lastly, for number 6, 6.73 times 10 to the power of 14. So there you have it. There's how to write numbers in scientific notation. I hope that helped. Thanks so much for watching. Until next time, peace.